Okay, this begins Chapter 1, Part 2 of our recorded notes. And we're beginning with powers of 10 notation, also known as exponential notation or scientific notation. It's a shorthand way of expressing either very large numbers or very small numbers. Now, when you put something in powers of 10, it has to be a number between 1 and 10, and you're multiplying it by a power of 10. So the power of 10 is positive for large numbers, it's negative for small numbers. So here we have the number 634. That obviously is not between 1 and 10. So you ask yourself, well, how can I make it between 1 and 10? Well, remember the decimal point is implied behind the 4. So to make this number between 1 and 10, I move my decimal point 2 places to the left. And now I have the number 6.34, which is obviously between 1 and 10. How many places did I move that decimal point? 2. So I'm going to write this as 6.34 times 10 to the second. Now, if my number is very small, like shown here, 0.000634, and I want to put that in exponential notation, scientific notation, powers of 10 notation, I'm going to take this decimal place and I'm going to move it 1, 2, 3, 4. So now I have 6.34, but now, because my number is small, it is now a negative 4 exponent. So basically all you're doing is counting the number of decimal places you move. Positive exponent if your number is large, negative exponent if your number is small. So sometimes you could see a number just written only as the power of 10. So if that's the case, then it's assumed to be 1. So for example, if you just see 10 to the 5th, you know it's 1 times 10 to the 5th. Also, if we don't have an exponent, if our exponent is missing, so for instance, if you have 4, well, in order to write 4 between 1 and 10, it's already there. So you would just say 4 times 10 to the 0 if you were asked to put that number in powers of 10 scientific notation or exponential notation. Now, this is very important, how to put these numbers in your calculator. Okay. When buying a scientific calculator for this class, you want to make sure it has the E button or EXP button. You do not want to use this little caret symbol on your calculator that I'm drawing here to input scientific notation. I've seen errors made when people use that caret key. So one thing, when you enter scientific notation in your calculator, you're never going to use the X key. The X key is your times key. You're using the EE or EXP key. So if I want to enter 5 times 10 to the 5th, I'm going to enter it in this manner. 5 EE, or I could put 5 EXP and then put my 5. So basically, when I put in my calculator 5 EE5, that tells me it is 5 times 10 to the 5th. If you hit that multiply key, your answer is always going to be a decimal place off. So you don't want to do it. So let's do some examples. So in these, I'm asking you to put the numbers in powers of 10 notation. So 720, my decimal place is right behind the 0. So to get that number between 1 and 10, I have to move it 2 places. So then that's going to be 7.2 times 10 to the second. Next is 890,000. So I know my decimal place is between that last, or at the end of that last 0. So now I'm moving my decimal place 1, 2, 3, 4, 5 places. So my answer is going to be 8.9 times 10 to the 5th. Now 3.6, that's between 1 and 10. So, but you're told to put it in powers of 10 notation, so then that's going to be 3.6 times 10 to the 0. Okay, our next number, very large number. So our decimal place is right here. So we're going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our answer is going to be 4.9 times 10 to the 10th. And I got to erase. So let me put my jumps again, if you're following that way. Now our next one is a small number. So we're going to move 1, 2, let's erase that. That did not come out good. So let's start over. So here we're going to go 1, 2, 3. So we're going to have 1.4. Because it's a small number, it's going to be 10 to the minus 3. Okay. And our next one again is a small number. So we're going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 1.1 times 10 to the minus 11. Because remember, small numbers have negative exponents. So this exercise, what I'm asking you to do is basically take it out of scientific notation and put it in the normal notation. So here we have 3 times 10 to the minus 4. This exercise is good for you to practice on actually inputting it in your calculator. So remember, this would be inputted as 3 EE, and then you should have a plus minus button on your calculator, or maybe just a minus button at the bottom of your calculator, depending what type you have. Then you enter 4. Okay, so your answer would be 0.0003. If I take my next one out, 5 times 10 to the 2nd, my answer is going to be 500. Okay, my next one is 4.32145 times 10 to the 3. So my answer is going to be 4321.45. My next one, 6.9 times 10 to the 5, going to be 0.000069. My next one is going to be 101 with 6 zeros. So 101 million. And then my last one would be I have 4 zeros in front, 8126. And like I said, this exercise is great for you to punch things in your calculator and make sure you get the correct answer that I've shown here. Okay. Now we go to some practice in our calculator where we're going to put the numbers in, and we're either adding, subtracting, or multiplying the numbers. Okay, and I'm asking you to write each answer in scientific notation. So when you do this for our first one, you should get 2,300. Now when you put that in scientific notation like you're asked in the question, it will be 2.3 times 10 to the 3. Some of your calculators you can program to always give you the answer in scientific notation. Others you'll just have to convert it to scientific notation once you get the correct answer. Okay, our next problem, you should get 1,700. And when we put that in scientific notation, we get 1.7 times 10 to the 3. Our next one, we have our answer 378, and that would be times 10 to the 0. And then our final answer, we have 6912 and 1, 2, 3, 4, 5 zeros and a 6. So that answer would be 6.9 times 10 to the 9th. So again, practice. Now, another topic we deal with is significant figures. Okay, and significant figures is something we always want to try to adhere to in physics. Sometimes you'll notice I don't really adhere to it. I forget about it. Sometimes I'm very stringent. On the test, I would ask you to put your answer in correct significant figures if that's what I'm looking for. So let's go over these rules for significant figures. Okay. First off, our digits 1 through 9 inclusive always are significant. So the example I give you is 14.235. Every digit in that number is between 1 through 9 inclusive, so it's going to have 5 significant figures. Another rule is leading zeros do not count as significant. Leading zeros are any zeros in front of the numbers 1 through 9 inclusive. So here we have 0.0045. Those zeros in front of the 4 are considered leading zeros. Hence, we only have 2 significant figures. Confined zeros are those zeros that are between the numbers 1 through 9 inclusive, and they will always count as significant. So here we have 0.6007. They have 4 significant figures because your 2 zeros are between a 6 and a 7. Now, when you have trailing zeros, which are numbers after the digits 1 through 9 inclusive, there's 2 ways that they can be significant. First, if you have a decimal point. So 62.00 would have 4 significant numbers. Or they're significant if you have an overbar. You see that horizontal line I have over the last 3 zeros? That would be considered an overbar. So in this case, you would have 4 significant because remember this 0 in front of the 2 is considered a leading 0. Now, when you do multiplication or division, you cannot have more significant figures than the least number of significant figures in the number being multiplied or divided. So if I'm multiplying a number that has 2 significant figures by one that has 3 significant figures, my answer must only have 2 significant figures. In regards to addition and subtraction, your answer can have greater accuracy than your measurements. So when you're adding or subtracting, your answer has to be reported to the same number of decimal places as that term with the least. So if I'm adding a term that has 1 decimal place and one that has 2 decimal places, my answer must be recorded in 1 decimal place. Okay, let's do some practice. So here I've given you a series of numbers, and I'm asking you to give me the number of significant digits in the following. So in the first one, I have 1,278.50. Notice I have a decimal point. So therefore, my number of significant figures would be 6. The next number is 120,000. Notice there's no decimal place, there's no overbar. So in that case, I only have 2 significant figures. My next number, I have 0.0053567. Remember, the leading zeros do not count, so that's going to give me only 5 significant figures. The next number I have is 823.012. That 0 is a confined 0, which means it is significant, so I have 6 significant digits. And then my next one is 2,653,008. Notice I have a decimal point and I have confined zeros, so everything in that number is significant, which gives me a total of 8 significant figures. Okay, now these coming up, what I'm asking you to do is do the operation that's listed and then give your answer in the correct significant figures. Now, sometimes in order to give an answer in the correct significant figures, you have to put it in scientific notation. That is an easy way to make sure your answer is correct with the number of significant figures. So in this first one, we have 23.4 times 14. So you get an answer of 327.6. Okay. But I see with my multiplication, I can only have 2 significant figures because 14 is 2. So I need to make this answer into 2 significant figures. So what I'm going to do is put it in scientific notation, 3.3 times 10 to the second. And 3.3 has 2 significant figures. In this next one, I have 0.0945 times 1.47. So when you plug that in, you get 0.138915. And now, again, I'm multiplying. My least significant digits are going to be 3, because this has 3, and this also has 3 significant figures. So in order to get my answer in significant figures, I can just round it and come to 0.139, and I have my 3 significant figures. The next one, I'm dividing 7.895 by 34, so I need to have 2 significant figures in my answer, and I get 0.23220588824, but I can only have 2 significant figures, so my final answer is going to be 0.23. Okay. Now, this next one is kind of a big string, so we can do it separately. So 4 times 972, we get 3888. 76.4 times 23.3, you get 2238.52. And then 12 times 7, you get 84. So now I'm adding, and I want to go with I have addition and subtraction as well as multiplication. So when I do this whole thing, I get 6042.52, or I can round it to 6,000. And I could also put it in scientific notation, which is 6 times 10 to the 3, because notice I'm going with my multiplication, and I just have 1 significant figure here, and I have to go with my least. So I need to have 1 significant figure. So I can leave it at 6,000 or put it in scientific notation. Okay, I'm going to stop here on section 2, and we will pick up with conversion of units.